if we want to use an antiderivative, we need to make sure we know our derivative functions. So the derivative of cos is sine, sorry, negative sine. So the integral of sine is going to be negative cos. Derivative of sine is cos, so the integral of cos is going to be sine. The exponential function is easy because going either way, it's just going to do the same thing because the derivative of e to the x is e to the x. So the integral of e to the x is e to the x. So the derivative of log x is 1 over x. So the integral of 1 over x is log x. Now there is an absolute value around there because the domain here, domain is going to be x is all real except for x not equal to 0. And the domain here, we need to keep the same domain here, okay? Because it's when we anti-differentiate this function, we need to be able to plug in the same x's into this function here. So this is just some practice with differential equations or anti-differentiation. This is given as a derivative. So what's implied is we need to solve for the antiderivative. So I'm just going to show you something which kind of relates to area. Now we don't really need to think of this, but because really we can just think of this as use the power rule. 4 to x, the power goes to 8, divide by that power, and then add the c, so we get, x 8 over 1/2. X to the power 8. And this becomes over 2. Let's see, that's our y function. Okay. Now, this is how we can relate it to area. And it's a little bit conceptually hard to make that leap of faith, but there is this connection between that and area. So I'm just going to move the dx to that side. dy is equal to 4x to the power 7 dx. And then I'm going to add up or integrate this side and this side here. And so the sum of all the dy's gives us y. And we know that the sum of this area is actually has something to do with the antiderivative. Okay, now this is this is a bit vague here, and there's not quite the clear connection, but it is related to the area. Okay, so this is how we can kind of relate it to the area. But for now, we're just going to start with the antiderivative. We'll just know our facts, antiderivative facts, and we'll do it that way. So this one here, this one we have the derivative. What's implied is we want the antiderivative. How do you anti-differentiate this? Well, this is going to be hard the way it looks. So we're going to rewrite this expression. Okay, and we're going to rewrite it like this: t squared minus 3t plus 2 all over t squared. The reason why we do this is because if we then isolate the terms, we can then apply power rule to each part. Okay, so if we want to undo the derivative, we get x or t here. 1 becomes t. This is the log function. So we undo it using a log. 1 over t, the antiderivative is log. And here we want to undo this with the power rule. So it becomes t to the power -1. Okay, so that's why the negative is there in front. And then this becomes, we divide by this becomes power -1. So we get the power 1 in the denominator. And we have to remember to divide by 1. That's why it's negative. Maybe I'll rewrite it here and I'll do it in steps. So this becomes 2 t to the -1 power, and then apply the power rule here, plus c. So then rewriting this, it becomes log absolute value of t minus 2 over t plus c.